So in today's class, what we want to do is, we learned the coordinate geometry in the previous class, right? So we want to solve some problems and apply the learnings from that class for solving some word problems related to these concepts, okay? And does anybody in the class want to take a punt at it and say, what are the two theorems or the formulas we learned? Okay, guys, Rudrakshan. If you're talking, you have to whisper literally so that there's no sound coming here. So we learned two important formulas from coordinate geometry point of view. One is called distance formula and the second one is called section formula. Yeah. And I will write it down on the board so that it helps you guys recall it. You guys need to whisper, not talk. And stay where I can see you guys, because I'll not let you guys go anywhere where I cannot see you. So one is called distance formula, which is in a coordinate plane, if you have 2 points A and B, and the coordinates are x1, y1 and x2, y2, the length of the line joining the points is nothing but, the length of AB is nothing but square root of x2 minus x1 squared plus y2 minus y1 squared. Do you guys remember it? Are you able to recall it now? And the second formula that we learned is called this. I'm just writing it here. AB equal to square root of x2 minus x1 square plus y2 minus y1 square. So this is distance formula. The second thing that we learned was called section formula. And section formula is like this. If I have 2 points, let's say A and B, with coordinates x1, y1, x2, y2, guys, Rudraksh and Sivakeswar, I can still hear you guys. So if I have 2 points and I join them, it makes a line AB. A third point C, which can divide this into M1 into M2 ratio. The x coordinate and the y coordinate of C will be equal to such that x value will be equal to M1 x2 plus M2 x1 divided by M1 plus M2, and y coordinate value will be equal to M1 y2 plus M2 y1 divided by M1 plus M2. And I know everybody must be scratching their head. Yeah, don't do so much, otherwise what is the outcome? If you scratch your head so much, this is the future. Don't do it. Okay, so this is what the section formula says, and we saw how that formula is arrived or derived. Okay, meaning it says if you have 2 points A and B with coordinates x1, y1, x2, y2, any point on the line which divides this line into this ratio, the x and y coordinate values will be having a relationship with these 2 coordinates and the ratio. Okay, like this. How do you remember it? The x and y value will be m1 x2, m1 x2, m2 x1 by m1 plus m2. Y value will be m2 y1, m1 y2. So it's crisscross. That is how you remember it. Okay. Yeah, Dikshita.
So will the M1 and M2 like have that?
Yeah, obviously. So this is a variable right now. Tomorrow you will say, okay, the C is dividing this into ratio 2:5. This year M1, this year M2. Yeah. If there is, okay, this divides the line equally. So this is 1 and this is 1. This is M1, this is M2. You'll substitute the value here. And again, x and y coordinates will have value as well. Yeah. So this is a generic formula that we are arriving at, and how we apply is what we are going to deal with today. Okay. So to remember this formula, right? The section formula. Remember this sign, the crisscross. M1 x2, M2 x1. M1 x2, M2 x1 by M1 plus M2, and when you look at y, M1 y2, M2 y1 by M1 plus M2. Okay. So if you, as long as you remember this, you will be able to figure it out. Okay. So it's like your teacher is trying to teach something and you say no. That is what is the section formula. Yeah. Alright. So we'll see how do we apply and where do we apply it. That is how it will make more sense. Right? So in today's class, whoever has missed the class because of Holi celebration, they will probably miss the fun part of the formula. Okay. Who dropped out? Pranav? Pranav was getting tired of this section formula. Okay. Let me check. Okay. Yeah. Sorry guys. Hey Pranav. So now let's look at few sample problems where this comes into light. Hey Lakshita. Lakshita, can you hear me okay? Lakshita is very upset with me because I'm taking class on a day when people are supposed to celebrate Holi. Okay. So Lakshita, I hope you can hear me okay. So in the previous class we learned about two formulas related to coordinate geometry. One is called distance formula and one is called section formula. And if you don't recall it, you'll have to watch the video of the class but how that formula was derived. But today we are going to look at the application side of it. Okay. So now let's look at a problem that you want to solve. So that Deekshita, you don't have to deal with those x and y values, okay? We'll deal with actual numbers that make more sense. So this is my coordinate plane. I have 2 points. A with the coordinates as 3, 2 and B with the coordinates 7, 9. And somebody says find out the length of AB. How will you find it out? So in the coordinate plane, I have 2 points A and B. A's x and y coordinates are 3, 2 and B's coordinates are 7, 9. So let me do a quick recap for you guys so that you can relate. So this is called distance formula, meaning distance between 2 points in a coordinate plane. You have a point here and you have a point here. And both points are recognized by the coordinates, right? People say, where are you? Send me your coordinates. That is nothing but the exact location. This is the coordinate of this point. This is how you locate this point. This is the coordinate of this point. This is how you locate the second point. Yeah? Lakshita, are you with me, beta? Okay. So I'll keep on reminding just to make sure that you guys are with me. Arihan, are you with me?
Yes, sir.
Okay. So, and if it's okay, I would request everybody to keep their videos on. Rudraksh, your parents will be late by 5-10 minutes, okay? So you sit inside. It's kind of windy outside, okay? So these are 2 points. We are trying to find out the distance between the 2 points, okay? And that's where the distance formula helps. Now, for everybody to visually understand this. Now, if you look at these 2 points, how do you find the length? You just join these 2 points. This is what will be your length. Yeah. So Vasundhara, you joined just now, a little bit late, so I'm just we are just trying to do a little bit of practice with what we learned in the previous class, which is nothing but called coordinate geometry. That is where we learned two formulas. One is called distance formula and second is called section formula. So we are doing some practice with those formulas. Okay, and I'll try keeping it as simple as possible so that you guys can follow it. You don't have to memorize the formula. Okay? I have 2 points in the coordinate plane, A with the coordinates x and y coordinates as 3, 2, and second point B with the coordinates 7, 9. And we are trying to find out the length of this line, the distance between A and B. Yep. So now how will you find this out? So this is 3, 2, meaning the x coordinate distance is 3. 2 meaning this distance is 2. Do you guys agree? 3, 2. This one is 7, 9, meaning if you draw a perpendicular from here to here, this distance is 7. Correct? 7, x coordinate is 7, y coordinate is 9, meaning the distance from here to here is 9. Yeah? Is it digestible so far? Yeah? Okay. Now we are trying to find out this length. So now think of this as a right triangle. What I'm doing here is I have drawn the perpendicular from here to this line. So this looks like a right angle. Yeah? If I give a name, this point is C, then ABC, this is B, this is A. ABC is a right triangle, right? Everybody agrees? Yeah. So before we are continuing from where we had left in the last class, where we learned about the two formulas called distance formula and the section formula. Right now we are trying to solve some problems with the distance formula. Okay. And if you missed the last class where we talked about it, how the distance formula is proved, that you can revise. That you can watch the video of the last class to catch up. Okay. But even if you don't remember, don't worry about it. We'll catch up. Yeah, Rihan.
I got my answer.
Okay, but let's hold on to it. Let's not rush because I know these are little tricky concepts. So you can verify your answer once I complete this. So this is my right angle triangle. So I had AB distance to find. What I did was I dropped perpendicular, found this. This is my length. Here to here is 7. Here to here is 9 because this is my x and y coordinates. And here to here is 3. Here to here is 2. Now what did we do? We just dropped the perpendicular on this line and we got this. So this is a right angle triangle. So if I know this length and this length, I'll be able to determine this length by applying Pythagorean theorem, like you all guys know. Correct? Alright. So now all the kids who are joining now, I'll not repeat myself because otherwise we'll keep on repeating. And whoever has joined now probably will have to watch the video of this class for the missing part so that you can catch it. But ultimately we are trying to find out this length where this coordinate and this coordinates are known. So if I have to find out this length, I need to find out this length and apply and then we have to apply and then we'll apply the Pythagorean theorem because this is a right angle triangle. So this length and this length, if we know, then you can find out this length. This length is how much? This length minus this length. So this length is, this part is the coordinate, x coordinate of the second point minus the x coordinate of the first point. 7 minus 3, this length is 4. If you want to know this length, how much is that? This length will be equal to this length minus this length. This length is how much? 9 and this is 2. So here to here will be 7. So 5 squared plus 7 squared. Pythagorean theorem says c square equal to a square plus b square, or c equal to square root of a square plus b square. So a is this, b is this. This is 5, this is 7. So 5 square plus 7 square, square root. This is 5 square is 25, 7 square is 49. So this becomes 25 plus 49. 60, 74, square root of 74. Was that the answer, Arihan? Okay. So the distance formula, I mean, we did not even bother about the distance formula. We just applied common sense for solving it, right? We just said, okay, fine. If I have the coordinates, I can find out the x and y length of both the points and then determine this side and then apply Pythagorean theorem to solve it. That's exactly what is the distance formula, okay? If you remember or if you don't remember, in both the scenarios, your distance formula says the distance between any 2 points with coordinates x1, y1 and x2, y2, the length of the line joining the 2 points x1, y1, x2, y2 is nothing but square root of x2 minus x1 squared plus y2 minus y1 squared. Yeah? And that is exactly what we did. So here for finding this length, we said, okay, this length minus this length. This length is x2, this length is x1. x2 minus x1 squared, 5 squared. This length is what? This whole length minus this length. So this is y2 and this length is y1. So y2 minus y1 squared. So that memorizing the distance formula is no big deal. Okay? Even if you memorize it or you don't memorize it, it still works because you can just visualize this in a coordinate plane and you should be able to solve it. Yes, Dikshita.
Sir, I got 65.
Did I make any mistake? 5 squared plus 7 squared. 7 squared is 1249, 5 squared is 25. It has to be 74. Just one second. Okay. Jayaji, can we do one thing? I have. I can do one thing. अभी क्लास चल रहा है, so we can talk on the phone also.
Okay.
ठीक है ना? आप पूछिए विद्यार्थी से उसको मजा आया कि नहीं आया? We will talk about it. ठीक है? तो मैं क्लास
थोड़ी लेट हो गए थोड़ा सा।
इसलिए मैं गाड़ी में बच्चों को रोक के रखा था। ठीक है? चलिए। बिल्कुल same time. All right. Sorry. So, Dikshita, your question is answered, right? It cannot be 65, it has to be 74. Because you got this length as 5 and this length is 7. So 5 squared plus 7 squared, square root.
How did you get 5?
So, see, this one was 3, 2. So x is 3 and this is 7. Okay, yeah, you are right. So this is not 5, this is 4. So this has to be 4 square. My bad. 4 square is 16 square. 4 square is 16 and this is 7. So 49. Yeah, you're right. See? So this is called blessing in disguise. Meaning if the teacher goes wrong and if the kids are paying attention, you're good. So Arihan, did you get 74 or 65?
After checking my answer, I got 65.
65. So Arihan and I made the same mistake. I making mistake is still okay because I will not be able to fail. You guys will get less score, okay? So pay attention, okay? Alright, but regardless, ultimately the message here is how do we approach it, okay? So calculation goes wrong and that is where practice plays a very important role. But net, we have to always look at practicing more so that your chances of making mistake is less. Yeah? So before I move on, Nihan, Sanvita, Vasundhara, Bivwan, is everybody with me? Yes. I know some of you joined late and I was not expecting this many kids to be in the class today because of Holi. I myself went to the temple for celebrating Holi and then rushed back home because I knew that I have classes. But whoever joined or whoever could not join, this was anticipated to be a class with less presence. That's why you don't see Ritika, you don't see many of the kids. And again, courtesy spring break also. Alright, so distance formula is simple. Now, if anybody gets 2 points, A and B, if somebody says A is minus 4, 2 and B is 4, 6, find out the length of the line. You will say, okay, fine. I know distance formula says square root of second coordinate minus first coordinate. Second coordinate of x. So second coordinate is 4 and minus the first coordinate. Square of that plus second coordinate of second point, that is 6 minus y coordinate to the first point square. So this became 4 minus 4 is 4, minus into minus became plus 4 square plus 6 minus 2 4 square. Okay, and you will find out the answer. Let's not worry about that part. Now what I want you guys to understand is, though the distance formula says that the length of this one is y2 minus y1 square plus x2 minus x1 square, meaning second point minus first point, x coordinate, y coordinate, difference. Whether it's y2 minus y1 square or y1 minus y2 square, both are same. Okay, don't worry about it. Whether you do y2 minus y1 or y1 minus y2 square, x1 minus x2 square, is the same, because it's ultimately it's a difference. Okay, difference of the 2 points. Okay, so even if you forget the formula, don't worry about it. You have to just find the difference of the y coordinate and difference of the s coordinate and do the square of that. That's it. Confused? No?
No.
Yeah. Okay. So this is the distance formula. Now you can always apply the distance formula. So I'm not going to talk about this distance formula anymore. I will try to trouble you guys with little interesting problems. Now, I have 3 points here, A, B and C. Okay. I want, let me make it little easy for you, little easy, only a little. Okay, I'm saying that 3 points A, B and C with the coordinates 2, 5, 6, 11, 8, 5. Find out the area of this triangle. So again, I'm repeating myself. Okay, I have 3 points A, B and C. A with coordinate 2, 5, B with coordinate 6, 11, C with the coordinates 8, 5. So if I have 3 points, if I join them, it makes a triangle, right? I'm saying find out the area of this triangle. How will you find it out? And don't tell me that you guys don't know what is the formula for area of triangle, right? Everybody knows. Half into base into height. I'm giving you the formula itself. But I want you guys to find out the area of this triangle. Don't try solving it. Tell me the approach. How will you go about it? I will solve it for you. I just want to know the approach from you. I want to rather learn the approach from you. So Sanvita, Nihan, Arihan, Gitesh, Dikshita, Vasundhara, anybody, okay, Bhuvan. Teach your teacher, how will you go about it? Yeah, Pranav.
So first I would subtract the x-axis between A and C, which gives me like the length of the base.
Mm-hmm.
And then I'll subtract if the y-axis from the base to the tip of B, which gives me the height, and then I find out the area of the triangle using the formula.
Okay, that's one approach. Let's see what Dikshita has to say.
So first you find out the A to B distance, and then find out B to C, and then C to A, and we add them all up, and then we divide by 2.
But what will that give me? If I add all the lengths, so I have a triangle. You're saying that we'll find this length by applying the distance formula, this length by applying the distance formula, this length by applying the distance formula, and if I add them all, that gives the perimeter, right? And if I divide the perimeter by 2, that is not the area. So think a little different. I want to think. See, I'm not in a hurry to get the answer. I want to force you guys to think about a solution. Yes, Neha.
Maybe I think you have to find the distance between A and C for the base, and then find the distance between A and B for the height, and then add them up and then divide them by 2.
You're saying you'll find this length and you'll find this length and then add them and divide them by 2? No. Okay, let's see what Arihan has to say. Yeah, Arihan.
Maybe you just you split that triangle into 2 right angle triangles, and then you find the area of both, and then add them up.
Okay. Little out of the box, but yes, okay, I'll still take it. Yeah, Pranav.
So the same thing. So subtract the x, A and C x-axis, so I can find the base, and then do the same thing with the base and B, so I get the height, and then multiply the base and height, and then divide it by 2.
Okay. Let's see what Vivon has to say. See, solving this problem is very easy, okay? It's only about how you're going to approach. That's why I'm stressing on this one and making sure that you guys think in the right direction. Yeah, Vivon, go ahead. Vivon, you were trying to say something. And Lakshita, Vasundhara, I want you guys to also speak up, okay? It's okay. If you make a mistake, it's okay. You saw me making mistake, right? If an old guy can make a mistake, you guys are babies. Don't worry. Yeah. Do you guys feel bad if I call you guys babies? For me, you guys are babies only. I treat you guys like babies.
That doesn't bother me.
Yeah. No. Okay. Yeah, Bhuvan. Okay. Yeah, Gitesh.
Can I tell you what I got for the area of it?
No, I'm not interested in that. I'm only interested in the approach right now. So tell me the approach. That is what I will appreciate.
So what I did was I did the length of A and C, which is 6, and then I did the if you go A and B straight, for the height you just have to minus 5, I think.
From what?
No. 5 from 11, and then you get 6, and then 6, and then I did 30, and 6 times 6 is 36, and then 36 divided by 2, and that's 18.
Okay, I think you were going the right direction, but you lost track somewhere in between. Okay, so fine. Very simple. If somebody says find out the area of a triangle, if this is my triangle, how do I find the area of it? I just need the base and the height. I just need these two things. That's it. So that is where this annoying method of mine is so important. Analyze. I'm saying by putting the points, ultimately I am coming to a triangle. And if I have a triangle in place, how do I find the area of a triangle? What do I need for finding the area of a triangle? I just need the base and the height. Now look at this triangle. Can I find the base by looking at this? I am still doing the analysis, I am not doing any calculation. Can I find the base? Yeah, I know the distance formula, I can find the base using that. Can I find the height? Yeah, let me see. What do you mean by height? I need to find out here to here this distance. I know this distance by the y coordinate, and I know this distance also by knowing the y coordinate of see here, this is a straight line. So here and here the y coordinates are the same, meaning this distance is fixed, 5. So I can find out this length, this height. If I find out the base, if I find out the height, area of a triangle is half into base into height, as simple as that. Can I find the base? From here to here, it says, distance formula says, distance between A and C is x coordinate difference and y coordinate difference square. Square of x coordinate difference. So x coordinate is here 8, here it is 2. 8 minus 2 is square. Plus y coordinate difference square. Both the y coordinates are same. So 5 minus 5 square. This gave me 8 minus 2 is square, 6 square. Plus 5 minus 5, 0 square is 0. So square root of 6 square, which is nothing but 6. I got this length is 6. How much is this length? So this y coordinate from here to here is 11. So this length is 11 and this length is 5. So this length is also 6. So half into base, which is 6, into height, which is 6. 36 divided by 2, 18. 18, if this one is centimeter, 18 centimeter square. So what I am trying to say here is, be it distance formula, be it formula of a triangle, area of a triangle. Yeah, Nitesh?
In what I did, I forgot centimeters square.
That's okay. That's fine. So see again, I mean, I did not say centimeter, right? I had just given you coordinates. So you will be at 18. That's fine. The unit is not given anyways. So what I'm trying to say here is, you guys will keep on learning formulas, different methods for doing calculation, and always treat those formulas as your enablers that will help you solve things or do things in a easier way. It is not to get you guys stressed out. You can as well find out the area without knowing the distance formula, because just by looking at this one you can see that this is a straight line and both have same y coordinate, meaning this is a horizontal line. So if I know that if I want to know this distance, I need to just look at this distance minus this distance. That will give me this distance, right? So a lot of things will be clear when you draw it. So get in the habit of making your boards dirty, your notebook dirty. Get your hands dirty. Yeah. When you do the scratch work, when you see, you will not be able to visualize everything. Okay. You have to use your scratch work for visualizing things, and then you try solving it. Now question to Lokchita, Sundara, Arihan, Nihan, everybody and myself. Okay, including myself. Whatever I explained, were you able to relate? Was it looking like something which is coming out of the blue or something that is digestible?
Something that's digestible.
Wonderful.
Digestible.
Okay. So that's why we should only eat as much as we can digest. So we should learn as much as we can appreciate. I mean, these are analogies, right? So that's what I'm saying. So when you learn something, it's not about how much you learn. It's about how much you could retain, understand and relate. Right? That's why I keep on asking you guys, right? I mean, I can finish the entire syllabus in 2 months if I run like a super fast express. Right? But that is not the goal. The goal is I should go fast enough that I'm not wasting everybody's time. At the same time, we should learn enough to be able to do it ourselves. Alright? Everybody with me so far?
Yes, sir.
Okay. Now, let me give you guys one more interesting problem. So I'm saying a child, so this is the tower, okay? Yes, Dikshita.
So where did you get like the height for the triangle?
How did I get the height of the triangle?
No, like what was it? Is it like 6 or?
It was 6. Because our points were like this. I had purposefully kept point A with 2, 5 and point C as 8, 5. Because I wanted to keep this a straight line so that your calculation becomes easier. Otherwise, finding out this height of whatever it was, B. See, ultimately to find out the area of a triangle, I need to find out the base and the height. So this height, it was I think 5, 11 if I'm not wrong. So I was saying that if you find out this height, by knowing the coordinate of this one, you will know this height. And I kept this line straight so that way it will be easy for you guys to visualize and subtract it, okay, to find the height. Yep. If I would have made it little difficult here by saying, okay, C is not 8, 5, C is 8, 7, then the triangle would have been something like this. And then for you to find out the height, if you had to look at this as a base, then you have to drop a perpendicular like this. And that would have been more interesting. That's why I picked up a little easier one from a solution point of view. Yeah?
When I did the height, I got 7.2.
But how did you? But yeah. Why did you get that? Or how did you get that?
So I did 6 minus 2 and I got 6 minus 2, I get 4 squared plus 11 minus 5 equal to 6 squared, and I did 52, I get 52 square, 52 square root.
Okay, so
and then I got 7.2.
So what was your coordinate for this point C? Was it not 8, 5?
It was 8, 5.
So then it will be 6. 8 minus 2, this will be 6. So here, this length AC is nothing but 8 minus 2 square, 6 square, plus y coordinate, difference of y coordinate, which is y, both are same. So 5 minus 5, 0 square.
I was asking for AB.
AB. But we don't need AB here, right? Because if I'm taking this as a base, I would take this as a height. I would not use AB, right? If I'm using AB, then I need this height from this point to this perpendicular line. And with the given information, that will be difficult to find, isn't it?
Yeah, okay.
Yeah. So basically, see, if you have a triangle like this, let me complete. I'll come to you, Gitesh. Dikshita, okay. So I'm saying, if I'm taking this as a base, I need this height. If I'm taking this as a base, I have to drop a perpendicular and find out this height. If I'm taking this as a base, then I have to drop a perpendicular from here to here and then find out this height. So, depending on which base you are choosing, you have to determine the height. And given this situation, since we were taking this as a base, we had to find out this height, and that was easy to determine. If we would have picked this as a base, finding out this length is no big deal. But then how do you determine this particular distance? That's the question. Yep. Make sense?
Sir, didn't you get
No, you're talking mute.
For the height, didn't you get like 6?
Yeah, I got 6.
How did you get it?
Because this y coordinate is 11 here, and if you look at this line, every point has the same height, because between A and C your y coordinates were 5, so this is a horizontal line. Every point on this, the y value is 5. So this is 5 and this is 11. So how much will be this height? 11 minus 5, that will be 6. Yeah?
Oh, I get it, sir.
Yeah. Lord Ritika, happy holi beta? You got a little late today.
Yeah, sorry.
It's okay. So today, we are not learning anything new. What we are doing is the coordinate geometry formulas that we learned last week, which is distance formula and the section formula. We are trying to apply that. We are trying to practice those to get more conversant with those. Okay. So whatever you missed, you'll have to watch the video so that you can practice some. At least you can relate to why did we learn the distance formula and how do we apply that. Okay. And I wanted to kind of look at the section formula also. At least do one problem with section formula and see how do we apply that. Yeah. So let's deal with the section formula a little bit. And if any of you, I know sometimes you guys have multiple things going on. If you miss any class and you end up watching the video of the class and then you have some confusion, each and every child in the class has direct access to my mobile number. Send a WhatsApp message with the question that you are struggling with, and I promise that I will solve it before the next class, okay? Or if I miss, I will come back to you and explain that in the next following class, okay? So never hesitate, don't be shy. There is not even a single question in the world which is wrong, okay? Yeah, Pranav.
Can we do harder shapes?
Yeah. So see again, there is no for me math is never hard. I always feel that you only keep your concepts right. You think about a problem before you try solving it, and then you should be able to apply that with your understanding of things. So let's say if you want to talk about a harder shape, let's say that we'll probably go to section formula today if the time permits, which I don't think it will. But let's look at a harder shape. Okay. Let's say I have 4 points here. I said 4 and I put 5 points here, okay, right? That is what an old man does on a holiday. Okay, so let's say there are 5 points here. Okay, this one has coordinates, let's say 2, 1. This is point B, which has coordinates 8, 1. This is the third point C, which has coordinates 8, 7. This is the D point, which has coordinates, let's say 6, 15. And this is the fifth point E, which has coordinates 2, 7. I am saying find out the area of the shape which is joining all these 5 points. And you guys know the distance formula, and you guys know the formula for all the shapes, at least the basic shapes, be it rectangle, be it triangle, be it quadrilateral, be it a square, be it a circle. Yeah, Vitesh.
Should I explain how I would do it?
No, first you do it. See,
Okay.
I always look for concepts, but concepts is an outcome of how you visualize it, and visualization cannot be done in air. You have not got enough time to even sketch it on a notebook. No, sketch it. Without sketch, see, there is no shortcut to success. Get your hands dirty, okay? Otherwise, you'll go wrong. So I first want everybody to see the points, understand it, visualize it, and then try explaining it. Because if you don't do your homework, the likelihood of you going wrong is very, very high. So I have given 5 points here in a coordinate plane. Point A with 2, 1 coordinates, point B with 8, 1 as coordinates, point C with 8, 7 as coordinates, point D with 6, 15 as coordinates, and point E with 2, 7 as coordinates. I want you guys to find out the area of this one, but initial 2 minutes for drawing it or sketching it, next 2-3 minutes for putting your thoughts together, and then you can explain. If anybody is trying to answer it in less than 5 minutes, I will have my doubts in place. Okay, so I'll go on mute. I'll keep on gulping water and see how you guys are approaching it. Okay. Before I go to Pranav, I'm assuming everybody is trying it, right? Lakshita, Ritika, Vasundhara, Sanvita. Okay. Because some of you are much more quieter than me, so that puts me in a doubtful situation. Okay. Let's go to Pranav. Yeah, Pranav.
Sure, I got 84 squared because I subtracted 2 and 6 because they're the lengths of x, and I got 6. And the same for the top, 7 minus 1, which gives me the y height. Since I'm finding for the square first, if I make a line between E and C, I have a triangle and a square. For the square, I multiplied 6 times 6, which gives me 36 squared. And for the triangle, I got 6 times 8, which gives me 48. 48 divided by 2, which gives me 24.
Okay.
20, which gives me 24 plus 36 squared gives me 70 squared.
Okay. Okay. So
Sorry, I meant 60 squared.
So I can tell you with confidence, Pranav, that you got how to solve it. Okay. I'm pretty sure you solved it right. Okay. But the only thing where I see an opportunity is you could have articulated this little better. I'll come to that. Okay. So let's see who wants to go next. Because when I say articulated, meaning how do you explain to somebody who is a 3rd grader? I'm a 3rd grader right now. Okay. So that is where the way you explained it, probably everybody in your friends group will understand this. I might not, being a 3rd grader. Let's say what Arihan says. Yeah, Arihan.
So since there's like a rectangle on the there's like C, D, E, that's a triangle, but I'm gonna like take that out for now, and I'm gonna do like A, B, C, D, A, B, C, E, and find that rectangle, which I don't think it's a rectangle. And where I got the area of that is 6 times 6, which is 36. And for the triangle, I got the height as 8, and 8 minus 2 is 6, and I did 6 times 8, which is 48, and then I divided that by 2, which is 24, and then I added 36 plus 24, and I got 60.
So I think Pranav and Arihan both got the answers. Just because we don't have much time left in the class, so I'll tell you. Okay, Gitesh, do you want to give it a shot, or you want to explain?
I'm still solving.
Still solving.
To be done.
Okay.
I think give me 2
So,
minutes.
okay, so I will not give 2 minutes because I just wanted to tell everybody how I would want you guys to articulate this kind of problem. Okay, how would you think about it? So as soon as you get this question, the first thing you will do is join them. Then okay, fine. I join these points one after another, and as soon as I join it, it is a pentagon. Do I know the formula for area of pentagon? We don't, and we don't need to. Now, again, excuse me for my fantastic drawing skills, okay? But when you look at it a little carefully, here for this line AB, your y coordinates are matching, so this is a horizontal line. So that means your total length is going to be this minus this, which is 6, as you guys found it out. Wonderful. Now, when I look at these 2 points, B and C also, this is a perfect vertical line because the x coordinates are matching. So this is a straight line, 90 degree. Okay, 90 degree with the base. And then you saw that okay, this height would be this minus this because it's a straight line and a perpendicular line. So we're not worrying about the x coordinate. 7 minus 1, 6. We got this 6. Same thing here also. The x coordinates are matching. So this is a perfect perpendicular line, and again the length is 6, and this is 90 degree. So, and here also same thing between E and C also found that it's a straight line because my y coordinates are matching. This is a perfect straight line. So from this you can see that all the angles are 90 degree and the sides are 6. So this is a perfect square. Same thing if you look at this triangle, so basically when you join these 2 points, this became a square and this is a triangle. Here in this triangle, what did you see? You can easily find out this base. This length is known 6. Only thing you need to know is here to here, this height. And since these 2 lines are straight lines, finding out this length is easy. So when you have to articulate this, you'll say, okay, fine. When I connect all these points, I see this is a horizontal line, this is a horizontal line, this is a perfect square, and this is a triangle. So I can find out the area of this square and I can find out the area of this triangle to determine the total area. So this area of this square, easy peasy, not to worry. Here I need to know the base and I need to know the height. Base is known to me, same as this one. And what is the height? This height will be a difference of this minus this. So the whole, this height minus this height, if I do, I find this height. And here to here is 15 and here to here is 7. So this part is 8. So by looking at this one, by joining the points, we can see that this is a square and this is a triangle, where for the square I can find out the area, for this triangle I can find out the height, and if I take this as a base. Now every calculation that you will do after that, I don't think I have to poke my nose into it. So it's about, you have the points, once I join it, see, now if you go back to my most boring technique, forget about this one. When you are reading this question, what you are doing is you are actually joining them. And when you are analyzing them, that is when you are realizing that these are my straight lines, these are my vertical lines, which helps me make this is a square and this is a triangle. And once you are done with this one, analysis, you have found out that okay, this is my square where I know the sides, and this is my triangle where I know the base and the height. Nike is easy peasy. Yeah? Yes, Anvita.
When you found the total height, like instead it was 15 minus 6, wouldn't that be 9?
No, this is not 6, beta. This is 7. See, look at this. This is a horizontal line. Here your y coordinate is 7 and 7, meaning this line is horizontal. From here to here is only 7. And here, yeah?
Thank you.
Yeah, Gitesh.
So is the total 84?
I would not know. Now it's up to you guys to know whether you know the tables, whether you know the multiplication. Because we know this is 6 and 6. 6 into 6, 36. This is what? This is 6 into 8. 6 into 8 divided by 2. This is 24.
Oh, I forgot divide by 2.
So, yeah, Dikshita. Dikshita, you're saying something.
How did you what's like the total answer here?
36 plus 24? 60? So basically, see, this is area, right? How much space it will take on the board. If I find this area, I'll add them together. And this is essentially what you will do with problems which is relating to composite shapes. You look at the composite shape, break it down into smaller pieces or simpler shapes that you know of, and then find out this area of each and every shape, put them together, you're done. Now, question to Ritika, Vasundhara, Lokchita, myself. Is it clear? I know some of the things might be. There's so many thumbs ups. I like thumbs up. That's a drink that you get in India, right? You don't get thumbs up here. But yeah. Alright. So I hope whatever we did today, at least with the distance formula, that was relatable. Tomorrow's class we'll talk about the section formula and look at some of the word problems that we can deal with. Okay. And see how that section formula helps us to solve some interesting problems. Only thing I would want to write again here for the kids who have joined a little late, the section formula talks about if I have 2 points A and B with the coordinates x1, y1, x2, y2. If I join these two, you guys know how you apply this distance formula to find out the length. Now, the section formula says, if I pick a point C here, without knowing the x and y coordinate, which divides this line into this ratio m1 is to m2, the coordinates x and y of this point C, which is dividing to this ratio, would be such that x will be equal to m1 x2 plus m2 x1 divided by m1 plus m2, and y equal to m1 y2 plus m2 y1 by m1 plus m2. And you guys must be thinking that what this old man is flexing here right now. I'm not flexing anything. This is something that we learned in the previous class, and we also proved how do we derive this formula. So we will just apply that for solving more problems in the class tomorrow. Yep, yeah, Rihan.
I think I just found an alternative.
You find?
You use distance formula. This only works if your C is dividing your line into a fraction.
Alright. Yeah, so
you can just find distance formula and divide it by that.
So again, every mathematical problem that we come across, I can assure you guys that there could be 2 or 3 ways of solving the same problem. Okay, it's about how do we visualize, how do we relate the concepts, and then we apply it. So I would never dare to say that whatever we learn in the class, that's the only thing. Actually, whatever we learn in different classes, right? I mean, let's say we learn something in algebra, something in trigonometry, something in geometry. You, based on your interest or comfort with a particular topic, you would be able to determine different approaches for solving it. Okay, so I would not eliminate the possibility of having different ways of solving the problem. Okay, So we'll deal with this tomorrow. Okay, we'll see. Yeah, Dikshita.
What's the whole point of section formula?
So the section formula is, it's like when you have 2 points, you can find the length, and then we dealt with how do you determine the area of the shapes and all that thing. Here the section formula tells you that in what way you can split a line. Now you think about a scenario. Okay, if I say that, okay, fine, if I'm going from this place, let's say somebody is walking along this line, okay, goes from this point to this point, okay, at what speed this guy moves, so that if let's say if you are let me give you an example here. So by section formula you are trying to say, okay, fine, these are 2 points and I'm trying to find a point which will divide this into 2 parts, into ratio, right? That's what we are trying to do. Now you can relate it with different scenarios, that okay, if let's say you have a boy staring at 2 buildings, okay, and this is the distance between the 2 buildings. Now let's say this building was smaller than this one, if you are standing here, you will not be able to see the roof of this building, correct? So people will say, okay, fine, find out the maximum height of this building that this guy can see from here. Let's say if this is one building and this is second building, okay, and let's say you have a friend standing on the roof of this building. What is the tallest building where your friend can stand, which is let's say 30 meters away from this building, where a boy standing here can see this top? I mean, I don't know if I gave the right example or relatable example or not. Think of a binocular, okay? You have a policeman standing here and there are 2 buildings standing next to each other with some distance apart, and this guy is doing vigilance. Can he see somebody standing on this building's rooftop by being here? So all this you can relate. When I kind of try solving few problems, right, for few word problems tomorrow, you'll be able to relate. Simple example is, this policeman can see the rooftop of 2 buildings which are let's say this much apart, okay. This guy is let's say 20 meters away from this. What is the maximum height of the building that he can observe from this place? So this is just, I'll leave it to your imagination for now, because when we pick up some real word problems and then we try applying this, you'll be able to appreciate it more. Maybe I'm a little tired and giving you some vague examples. So hold it till tomorrow. I'm sure when we look at some of the questions that we try solving tomorrow, that will make more sense. I had prepared some questions for solving today, but just because I'm looking at the clock and we are already late by 7 minutes, and I know Pranav will say, sir, we are already on time. So that's why I'm holding it here. But when we try solving some problems, we'll be able to appreciate it more. Okay? Alright? With that being said, I'll let you guys go and see you guys tomorrow same time.
Bye, sir.
Alright, bye-bye. Take care.
Bye, sir.
Bye-bye, bye-bye.
Also,
Bye-bye. Okay?